Hi, this is a video walkthrough on exercise 7, which goes over man-in-the-middle attacks. Um, so to get started right off, what a man-in-the-middle attack is where a an attacker will position himself in between two entities in their line of communication. And the way they do this is by convincing each party that they are the other. So, in terms of this exercise, we will be targeting the communication line in between our PLC and our HMI. So, our Kali box will convince the PLC that it is the HMI, and it will convince the HMI that it is the PLC. So, once we position ourselves in between those two entities, um, we can actually receive packets that are meant for the other party, alter them however we wish, and then send them off to the receiving party in our altered state, and the receiving party will think that it is the original. That is without mitigations in place. Um, for this exercise, we will be receiving packets from port 502 on the PLC, which contains data for the Modbus and is going toward the HMI. So we will receive those, we will alter them so we can actually display whatever we want to on the HMI, and then send them off to the HMI to display. So to get started with the actual exercise, you would want to open up a terminal and make sure you have ettercap. And one easy way to do this is to just sudo apt update, and then once that's finished, sudo apt upgrade. And the upgrade will actually take a bit because it will find quite a few packages to upgrade, but then you will have ettercap. And so once you have that done, you'll want to go into the search and type in ettercap and then Kali. And on this screen, you just want to hit the check mark and we should be good to go. And as you can see over here, we have my traffic light sim that I built earlier that we've been running these attacks on running. So first thing we want to do is to scan our network and add hosts. So we go over to the three dots, hit hosts, and scan for hosts, and it'll scan. And then we can see down here that there were 5 hosts added. And so we go up here to the icon right beside the search, and we can see all of our hosts. And I know from previous reconnaissance that this dot 4 is the HMI and the dot 5 is the PLC. So we just want to click 1 and add to target 1 and click the other one and add to target 2. It doesn't matter which one goes to which, just make sure to remember which one is under target 1 and which one is under target 2. Um, so once we have our targets added, we want to go up here to the globe icon and ARP poisoning. Hit that, hit OK, and it should be poisoning going through that. And this is actually the process of getting in between the PLC and the HMI. So we're convincing the PLC that we're the HMI, and we're convincing the HMI that we are the PLC. So we're inserting ourselves into the middle of them. And we can actually see that if we go open Wireshark and we start a new recording. We can see, um, if I remove my filter, that we are receiving stuff and sending stuff to both. So now it is time to make our filters. I've gone through this lab myself and I've pre-written all the filters, but I'll be going through them each individually. And the first filter is to invert the lights. And I took this to mean that for one stack, if a light was supposed to be on, it would be off, and I would turn all the others on. And so, so this is the filter file, and you can see that we're sorting and for the protocol of TCP and also the source port of 502 because we want what is being sent from the PLC to the HMI. We don't want the requests that are sent from the HMI to the PLC. So that is why it is the source and not the destination. Um, and so here we are actually filtering for um, data coils when we're sending or reading data coils. So this is what this is, and these are referring back to the actual payload. So if we go over to a our Wireshark capture that we just did, and I find it easiest to just do IP.source equals our 10 or our PLC address, hit enter. We can filter for all of those packets that originate from our PLC. So here's our actual packet that we captured from the PLC that is headed toward the HMI in response to a request. And from this point on is actually the payload. And from here to right here is actually just unique identifying information and other stuff. But we really want to pay attention to this number right here. This is the function code. And this number right here is the one we also want to pay attention to, and this is our bit count. Um, this basically tells us how many of these segments there are. These two-digit numbers are, these hex numbers are. How many are actually, how big our data is, essentially. Um, and so this tells us we have 12 uh, segments of numbers in our actual payload. But this function code is super, super important because this tells us what exactly we're grabbing or what exactly is being sent. Um, this 03 is the function code for sending holding registers. So this packet is containing what is being held in the holding registers. What we are looking for is a function code of 1, and that means that it's sending the information for what's in our coil registers. So that's what we really want. And so here we can actually see here is our function code, and it is a 1. So that means that this is sending our coil registers. And you can also tell for anyone who followed my build when we're sending coil registers because it asks for all 800 or so coils in the request. So we'll see all of these zeros because it has to ask for all of those segments of eights because we separated our lights into two very separate positions in memory. So moving forward, we have 65 in hex. Keep in mind these are hex values, bits of data or segments of data. And this right here is our first bit of data. And so this, for anyone who followed, is what is stored in our east-west stack of lights. And this down here on the bottom right is our north-south stack of lights. And like in exercise 5 or 6, um, I think it was 5, uh, when we were dealing with the reading registers, um, this this is an 8-bit number corresponding to 8 registers in memory. So for me and anyone who followed, this number represents the first 8 registers because we stored stuff in the first 3. And so it grabbed, when we want information from those 3, we have to grab all 8. And so this is the number representing those first 8 registers. And this number is representing the registers 800 to 807. So going back to the filter, so this is telling EtterCap to go 7 bits past um, the start of the data and grab the function code. And if it is a 1, so go from here 7 bits 1, 2, or 0, 1, 2, 3, 4, 5, 6, 7, our function code. And if it is a 1, uh, it falls in here. And if the data plus 9, so this is our east-west stack 8-bit number, is equal to 00 or 04, and our last 8-bit registers 8-bit number is equal to 1. So this is asking if for that specific packet, if our east-west stack contains a green light and our north-south stack contains a red light. Because in our 8-bit number, the rightmost bit is our red light. The one directly left of that is our yellow. The one directly left of that is our green. And then the rest are just empty. We don't need those. But we grab them anyway. And so then it actually goes and prints out, this is for east set, oops, that's supposed to be east-west, but not really that important. Uh, East-west green and north-south red. And then it actually goes and changes. I went and changed that value to 3 because the activity is asking for the inverse. So I took the inverse to mean if it was a 0 before when we received it, I changed it to a 1. And I didn't really matter about past those 3 digits that we were actually using because we don't use them, so there's no point in actually changing those to 1, and I thought the math was a ton simpler than what it would have been. So our first 3 bits, 1, 2, and 4. So if 4 is on, that means 2 and 1, so change it to 3. So our first 2 bits are on. So our red and yellow should be on. And then going down, this one is checking for the function code of 1, checking if our east-west yellow light is on, and our north-south red. And again, inverses it. And same for the north-south stack when the north-south is green and the north-south is yellow. So now, once you actually build the filter file, you'll need to compile it. Um, so I found it easiest because of just the way I built it. I built it one section at a time to test if it was actually working. Um, I've found it easier to just name it something slightly different because when you went back in to edit it, it was acting a little weird. So to actually compile our filters, we need to type sudo etterfilter, our filter file name, -o, and this can really be anything, but I just named it something simpler and added an underscore filter. And it has to have, these files have to have the .ecf or they won't run. And if you type in the password, and it should come up with something like this. So now we are actually ready to filter our actual bytes of data, or our actual packets. So if we go back over to EtterCap and we go over to the three dots into filters, load a filter, go through the file system and uh, find the file that you compiled. So here, if you have two of the similar name where it cuts off, I guess, you want the one that says unknown. And then hit OK, and it should be applying the filters. And as you can see, this is the message that we set to display. And over here on the HMI, we can actually see it working. So whatever's supposed to be on is off and everything else is on. So green is on, or green is supposed to be on, yellow and red are on, green is off. And it goes through and does that for each individual light. So when you want to stop filtering the traffic, we can go over to the three dots again, back down to filters and stop filtering. And it will unload the filters. And the stream of data will go directly back to what it was because we're not actually altering anything. So now, uh, on to the second part of part three. We are told to turn all of the north-south lights on. Um, and so I did that here. So I basically, it didn't specify anything for the east-west stack, and so I didn't put anything. I took it to say that that stack doesn't really matter for this point. So this looks a little simpler. So again, we're sorting through for the TCP protocol and the source port of 502. And again, we're searching for, within those packets, those that have the function code of 1. So again, we're searching for those that are replying to a read coil request. And then we're changing uh, the north-south stack of our data into 07, which is for the first three bits all turned to 1. So 4, 2, and 1, 7. And so again, you compile it the same way. So I won't show that again because I already have all of these compiled. So if we go back to EtterCap and again go through filters, load a filter, and navigate back to all lights. We can filter in, and no matter what the east-west stack is, all three of our north-south stack lights will be on. So pretty simple. Uh, and I will go ahead and stop that. So now we are actually going to be performing a DOS attack with man in the middle, through man in the middle. Um, and so again, we'll be applying a filter. This will be using the drop command, and looks a little bit like this. Um, so in this filter, we are searching for anything that has the protocol of TCP, and then we want if it has the destination or the source port of 502, we just want to drop it. Um, So anything that the HMI sends for the PLC, we'll drop that. Anything the PLC sends to the HMI, we'll drop it also. So if we go and actually load the filter, DOS. There we go. Load it. And it might take a second for it actually to catch up. But then you can actually see over here that it just freezes because it's not receiving any more information. Uh, so you should have all of these yellow triangles with exclamation points in them telling you that it's lost connection. For all of these man-in-the-middle attacks and all of these filters, you won't actually see any effect on your physical board. And that's because we're targeting the connection in between the PLC and the HMI, which uses the internet, sending packets back and forth. That's how the HMI gets the information to display on the web browser, and the PLC actually communicates with the board through their serial port, and so it's unaffected by any of these attacks. But this has been a full walkthrough on how to complete man-in-the-middle attacks with various filters uh, described in Exercise 7. Thank you.